Hello everyone, welcome back again. This is Jesse, and then in today's tutorial we'll be taking a problem, and then we're going to analyze it and then try and use machine learning to do some predictions, right? So the data set we'll be using is the UCI. You can go to this website, and then that's the kind of data we'll be using, right? Thoracic surgery data. So the problem we'll be dealing with is we are trying to predict the life expectancy in patients who are having lung cancer, right, after they have done thoracic surgery, whether they're going to survive after 1 year or not. So that is the data. So this is the question that you are trying to solve. So let's see our data set. So let's see our data set. If you click it, you're going to give you this data set. So these are the attributes here, and then these are the data, right? Okay, so you can just save it and then you edit it. Now let's go back to here. So the first problem we are trying to solve is that we are trying to learn how to predict how long a patient with lung cancer will live after performing thoracic surgery. That's the first question. Then the next question we're going to try to solve or find answers to from our data is that we're going to find important features that can help us to know the life expectancy, right, after thoracic surgery. Okay, so first of all, let's load our libraries, which we have our EDA packages and this import pandas as PD, and then NumPy, and our visualization packages such as matplotlib as PLC, and then Seaborn as SNS. Okay, so first of all, let's load our data set. So we're going to call it a df is going to be PD for pandas, then read CSV, and this is going to be our data set, thoracic data. So it's going to load it for us, and then if I check for the head, it's going to give us this, right? Perfect. So this is our data set, which is quite interesting and quite nice. Now let's see some of the things we can see from looking at this data. We realize that there's an FFF, there's TTT. So F will possibly mean false, and then T will possibly mean true, right? So we actually supposed to convert these values into a format that we can work with. We should be supposed to convert them to numerical data. So first of all, let's do some descriptive analysis of this our data set. So we can just check for it in this format of df.describe to see our data set. Then from this, it's giving us, it is calculating the mean, the standard deviation for only the FVC, that is forced vital capacity, and forced expiratory volume, and then the age, right? These are numerical values. So that is why it's only giving us that. So if I check for the D types, that's giving to us that these are floats. The one that it was able to calculate the mean, these are float, and the rest are objects, and this integer. That's why it only calculated those ones. But you want the full statistical description for all of them, so you have to convert them into floats, right, or into integers. So let's check for our shape. So the shape of our data is df.shape. Going to list are 470 rows and then 17 columns. So let's see our columns. Then this is our columns. So these are our columns. So our columns are 17. Now, nice. So now let's see how to convert these ones into something that we can work with. But before we can convert them, let's check and remove out every missing values, right? If you check for it as head, you realize that there is no missing value, but in the first value that has been loaded. But let's do another one we can use to check. So here is null dot sum. So it's 0. So that means that there's no missing value among them. Nice, that is perfect. So now we can try and see whether we can be able to work and remove some of them out. So to remove them, I'm going to store them inside this df1, then df, so that we don't change our data set. So if I go back to this df1 dot head, let's make it 10. It's still the same data set, right? Okay, now we are going to move all these things, replace the f as 1, and then replace the t as 1, and then f as 0, and then all these things is for two more nodes, and then metastasis, diabetes, and then mi. So let's see how to do that. There's one simple way of doing it by using the replace, right? So df.replace, so t for true is going to be 1, and then f is going to be 0, and you're going to replace all these ones perfectly with numbers. Then you are going to bring this in place as true. If I do it like this, and I work on it, it has done it well, so that all of them, there's no more F, there's no more T, there's now ones and zeros, which is nice, so we can work with it. But because it is in place as, I did not bring the in place as true, if I go back, it still did not change. So the best way is to bring the in place is equal to true, right? So that it's going to actually change our data set perfectly. So that if I go back, everything has changed well. Now all of them are in numbers, so df1 dot d types. Then all of them are integers, right? Or float, so we can work with it now. Perfect. So let's see some visualizations about them. So from this aspect, now we can just do the next thing about it. That is, we can df1 dot describe, and then now it's going to work better for us than the previous one. Perfect. So now you see that it's giving us a more broader description of the count mean for each and every of the rows, because now they are in numerical value, either float or integers. Now let's see some visualizations of them. So with the visualization, we can first of all check for the histogram, right? So let's check for the histogram. We bring this one here, we check that one later. So we can do that by using df1 dot this for the histogram, and then I'm going to plot it for our data. So that's going to give us a histogram, a general histogram about how our data looks like. And after that, we can also check for, perfect. Now it has given us a general small, we can increase the size if you want, and give us, this is the age goes up like this, the asthma, and all these things perfectly. Okay, again, you can also check for the correlation. So let's check for the correlation. The correlation is going to help us to know the relationship between the attributes, right? The various attributes. So we can do that by using df1.core. So that you're going to see the correlation, and then you realize that from this data set we had, the correlation is perfect. 1 1 1 1 1 1 is the mean. So it's comparing FVC, false vital capacity, with false vital capacity. So 1 is the normal, and then as it goes up and down, so that you see whether it is closely related or it is farly related, right? It's not fully related to it. That is why it is 1. So that means that if and are fully related, that's why it's 1. If it is negative, then it's not closely related. Okay, this is good, but we want to see it in a better way. So one of the ways of seeing it is we can use what do we call it? I can use a heat map. Let me bring it up here. Use a heat map to do it. So let's go with, instead of CNS, right, we are going to use the SNS, that is for the seaborne, and we're going to call it that heat map. Then inside this heat map, we are going to pass in df correlation.core, and then I'm going to pass in another one for annotation. I'm going to set our annotation to be true, right? Perfect. And let's bring the plot first. Figure, and I'm going to give it the figure size of, and then let's say 20, and then let's say 15, right? So perfect. Now if you plot our, so that you can see this thing is the same thing we have done here. I think I made something. Perfect. So it's going to print it perfectly for us. It's going to do the same thing. Sorry for that. It's going to do the same thing that we had here in a pictorial format, so that you can be able to see it clearer. Perfect. Now it has done it well for us in this format, so you can see the same thing as we had for the previous one, right? This is the same thing as this one. This one is more presentable. Okay, now we have understood how our data set looks like. So let's check some other things. We can also check for the skewness, whether it is moving positively or negatively. You can do df1.skew. Skew, and I'm going to check for us. So the skewness is that if it is positive, then it is on the right. If it is negative, then it's on the left, like the graph that we have, the Gaussian distribution or the normal distribution. Skewness is not necessarily equal to Gaussian, but that's what I'm trying to understand about. Then 0 means this close. Okay, now you can also do density plots, which can be df, but we can do density plot if you want, right, to understand it. Okay, now let's move on to feature selections. So now we have got some data about it. we have got an understanding, but we want to know the best features that we can use. So to do that, we can just go with, there are three main methods, but we work on the two of them. We can use the select key best, which is going to select the features with the strongest relationship, right, with the output. And then we're going to do, can also do recursive feature element elimination, where we're going to identify the features which contribute the most by eliminating it up and down recursively. So let's first of all see our data, right? So df1.head. Looking at this data, we can realize that the output is risky. This is going to be our target, and then from here to here it's going to be our pages, right? So I'm going to create as s, and I'm going to make it df1.values. I have to drop this one because this one doesn't speak much. Either I convert it into numbers or I can just drop it, right? So I can either make it like this and then start from 1, right? This is going to be this number, so 1. Let's check it again. Let me check for the size first or shape. Okay, 17. So this is going to be 1. So I'm going to be dropping this one. This is 0, so I'm going to drop in this one. So I'm going to start from 1. I'm going to go all the way to, this is 7, so all the way to 16, right? So that if I check for this again, yes, perfect, right? Okay, that is nice. Now that's for our target. So this is going to be our features. So features, and now this is going to be our label, right? Our label data, label or target or our output. So we're going to call it as y, and then we're going to go df1. You can then put in this place. It's risky, right? Which is 0. So let's call it as risky. Risk 1, 1. Okay, perfect. If I check again, oops, perfect. We can also do it in this way. I don't think it will work, but let's try it. See, that is, it's not going to work. The only way we can do it is either we use like this, and then instead of we making it like this, we're going to make it like this, right? 16. This format, if we do it like that, it's going to work. So we can just do it like that, so that it's marked as well. And now we have got our features, and let's try and see which of the features is we should select, right? So we're doing it with from sk len dot feature selection import keybase, right? So select keybase. I'm going to do the same thing for chi squared. So that is chi to 2. So oops, chi 2. Okay. Now having done that, we can now work on our data, right? So that is it. So let's try and see using a model. You're going to use a model to check it, right? The model you're going to be using is going to be from sklen dot linear model using logistic regression, although the name is regression, but it's a classification model. Logistic regression, right? So after that, let's check it. Model, I'm going to call it model logit, so that we just know what kind of model we are working. And logistic regression, right? Perfect. So now we have loaded our model. Now let's try and see how we're going to call this our chi-square and then fit them together. So I'm going to call it skb for select key best, right? And then I'm going to call it as select key best, and it's going to take some function. So I'm going to call it score. This as an argument, store function score func is equal to the chi that we loaded, this chi. Then I'm going to call it a k is equal to 4. That is the number of k is equal to 4, right? Perfect. So from that, I'll call it skb fit. So going to skb.fit. I'm fitting it together with the features that we have, binding them together. Perfect. Did I make a mistake somewhere? So let's give face. Mistake. Let's change this. Right, so we're going to change this, and I'm going to make it df1. Risk1. Risk1. Okay. Let's try that one and see whether it's going to work. If it works, fine. Okay, perfect. Now it's working. Okay, so now let's see. From that, we are going to check for the sk best. So let's get best, right? Fit is equal to, we've already had it already, so I'm going to call it as scores. And then don't forget this bar, it's very important. Otherwise you may think there's nothing there, but without this it's not going to work. Then best, let's call it best features. So what we are trying to do is trying to find the best feature that we should rely on. sk fit dot transform, then we're going to call it as x, right? So it's going to print it for us. Now after that, perfect, and we can actually select the best feature. So the highest score will show which of the features are very good. So we can do that by using print. Then I'm going to call it, let's say, scores. Then I'm going to call it, I'm going to paste inside this one. Even without that, you can just paste inside this. It's still going to give us the results because we have already pasted it together. Perfect. So now I see that now the highest score is going to be our features, right? The one that we should select. So the highest score, so 26 is higher. We had okay, 4 is also high, 5 is high, 6 is high. So after that, you'll be checking these ones to see which of them is actually high. So there's a simple way of doing it to make it easier for you to know of mapping. Instead of mapping it up and down, you can do it this way. We can map them together. So let's try and see. So from this right now, I can also do something. I can check for a summary of selected features, right? So I'm going to just print then the best features that we had. The best features we had was from 0 to 15. 15 or 16. Okay, let's try that one and see. I think it's 1 to 16. Let's see. Perfect. So this is it. It's still something similar to this. So this is our best selected features. Now we can also do some other things. I can list all of them in such a way that I can look through it and then find it automatically. So we can have something like df.columns, right? So this is it. So I'm going to copy this one. It's an easy way. I'm going to call it my features, feature names, and then the next one I'm going to call is my best scores. So I'm going to list all of them, and I'm going to paste in my skb fit scores, which was from here. skb fit score, this one, right? It's what I'm placing here. Don't forget to bring the bar. Perfect. Okay, so for me, I'm going to map it. So it's going to be for, let's say, B, then F in zip. I'm trying to map it so that to just help me. This is just for myself. Best course my features, feature names. The zip is trying to zip them together. Now just print F. This is what Python 3.5 apples. So not all Python versions will work. Deals with this, right? I'm going to put inside feature. Then this format, so I'm going to put my F here. Def is for the feature name. I'm going to map it to my B, right? I think is it I multiply by 100 so that you don't see all these unnecessary numbers. Perfect. So perfect. Now it's working. Okay, it didn't work well. See the mistake I made. It's not supposed to be this. It's supposed to be square. Okay, we'll go back it. Okay, now perfect. So from this we realize that FVC, full vital capacity, is an important feature. FEV is also an important feature. This is also another important feature. So we are looking at the ones with the high. So this one is very important. TNM is very important. Weakness. So we know that if the person is having hemoptysis, he's having FVC higher, and then if he's having tumor, he's having weakness. These are very important features that we should be considering, right? So these are the main important features to be considering. Now let's do some other things. You can also use the recursive and also check it in the same way. Now let's move on to feature importance. Which of the features are very important? So to check for the feature importance, we're going to be using a stream tree classifier. So it's going to be from sklearn.ensemble, right? Import stream tree classifier, right? I said the stream tree, extra trees classifier. Yes, this is going to help us to show you the features are more important, because we now have selected the features that are very important, crucial, which is weakness, because it's for weakness TNM. Then we also had FEV, we had FEC, and then hemoptysis. Right now, we want to find which of them is more important to contribute to the output. That's why we are using this format. Okay, now so let's build a model. So model, I'll call it extra tree, and I'm going to do the same thing like extra tree classifier, right? So after that, let's model extra. We're going to fit it to our data set, which we had at S and then which we had at Y. Then after that, we're going to print model extra dot feature important. Let's go importance. Don't forget this one. There's an S here. Perfect. So now it's also doing the same thing like the previous one. So the higher the score, or the larger the score, the more important it is. So this is how it has done it for us. So you can just use the same thing that we did here, which was this thing that we did here, this whole function that we did here, right? You can just use it again. So I'm going to call it my important features. I'll just put it, and instead of my best score, I'm going to call it my important features. I'm going to put it as model. Let me put inside the list. Model extra dot feature, right? Important, right? And I'm going to put this one here. Perfect. So this is no more going to be feature. Okay, let's call it MF for my feature. And this is going to be MI for important, right? So this is going to be MF, and this is going to be MI. Perfect. So from this one again, you realize that the higher the number, the more important. You realize that FVC again is more important, just like the one we had here, whereby FVC was 2609 and then 149, and then we also had two more and then cough and all those stuff. Here again, with the most important feature, we realize that FVC again is 24. Then we also realize that cough was 3, weakness has come, TNM is okay. So like realize that FVC is very important in determining it, and as well as age. So these are some of the things you can know to know which of the features are very important, which of the features are to be dependent upon, and which of the features contribute the most to the outcome. Okay, now that is good. Let's see how to evaluate our model, right? So to evaluate our model, first of all, we will move on to the basic things that you can do. We'll be using the train test split. So train test split going to be from what sklearn dot model selection. This is going to help us in evaluating and selecting our right model. Selection, import train test split, right? And then I'm going to give it a seed of 7. The seed is 7. That is going to help us that we can be able to reproduce it, right? The randomness will still be producible. So I'm going to call it S train. This thing always test right train right test. And we are splitting our entire data by 80-20, right? By 80-20 or 30-70, depending upon how much you want it to be. Then I'm going to call it train test split. Then X is what you're going to be doing, and then we have Y, and then the size is going to be this, where you're going to put our 0. Can be 0.20, 0.30, but let's make it 0.30, right? Then the random, we're going to set the random to the seed. So we're going to random state. It's going to seed, right? Perfect. Now it has splitted our data for us. Now let's try and use our logistic regression on it. And by that you can even predict the accuracy of our model, right? So you'll be predicting our accuracy of our model. So we're going to use logistic regression, which we had already, which we had, if you remember, we did from sklearn.linear model, right? Then import logistic regression. This is what we did the other time. So because we did it already and we did logit already, I want to show it to you so that you can see what I'm talking about. This is the same thing. The same thing is here. It's what I'll be using here. That's the same thing, right? Okay. Copy and paste it. now. So we can just check for it by doing model logit dot fit. Then we are going to use some of them s train, then y train. And so after that, so s train, and then now let's check for this. So I'm going to call it score, then perfect. Now, right? Okay, now we can check for the accuracy of our model using this format of, let's say, print accuracy, then let's make it this way, and result. So if I go with this, it's printing it all, but I can make it better by multiplying by 100. So 83.974. So that is the accuracy. So our model now for the logistic regression is very, very accurate. So we can actually use it to compare several algorithms and then check on their accuracy. Now we have got an accuracy of this. Nice. So let's try and see whether I can be able to predict something, then we compare other algorithms. So let's have a value. Let's use the same thing. Let's try it with the s-test and see what we are going to have. So I'm going to call it new predict, right? I'm going to call it as model logit dot predict, right? Perfect. So from this point I can just paste in this, and then we're going to see the result is going to give it to us. So print new, this is using our data. Perfect. So 0 0 0 0 0, and it's perfectly working for us. Well, we like that this s-test is having several, this thing, see 156, so it's having several of them. So just predicted it that it is false. So 0 0 0 0 0 1 1 1. Okay, that is one. So we can also create a different one like this, right? So this is a data I picked from here. You can just create one. So df1 dot head. Just want to try something so that you just see. You realize that this is, the risk is 0. So I'm picking this same value, right? This value, and I'm going to tweak it, change it small. So I took the same value and then I tweaked it a little to see what it's going to give to us, right? I'm going to use that one to predict and see. So to predict it, let me go this. So let's check for the type. Let's predict. Then it's a numpy and array, right? Now if I'm supposed to check for the size of it, sometimes the reason is that you're supposed to make sure that it matches shape, which is 15. Okay, so let's try and see whether we can be able to use it to work on what we have already. This is seeing it as what, as 15 rows, but you want it to be 15 columns, right? Not rows. So we can reshape it. So s predict dot how do you call it, reshape, right? Then instead of making it -1 and 15, now it is. So if I go back again, let's save it as new x, right? Something like this, new s. Right, if I go back and I check again for the new s, new x, now perfect, 1 to 15. So this is better because this is the columns, different features. Now I can use that one and then check for it. So model logit dot predict. Then I'm going to pass in my new x, and let's see whether it's going to work. Wow, 1. So perfect, it's given us as 1. So now the value is 1. So Print. It's given us as 1, right? So that means that it is actually meeting our value. Remember that from here 1 was true, right, and F is false. So that means that the life expectancy of the person is less than 1 year for a person with this particular set of features. Okay. So thank you for watching this long tutorial. If you have any question or contribution, you can just put inside the comment section so that everybody can benefit. And please don't forget to subscribe. Stay blessed.